Hello everyone. I welcome you to this class of econometric methods. Myself, Dr. Imdadul Haq, an associate professor at the Department of Economics, Aligarh Muslim University. Today's lecture is an extension of our previous lecture we had on simultaneous equation models. We will see in details, the various things which we have defined in our previous lecture, like we will see this reduced form model, and we will also look for how identification happens with reduced form models and related things. So first of all, we start with what is a structural model. Structural model expresses the endogenous variable as a function of other endogenous variables, predetermined variables or random variables. That is, the structural equations express the endogenous variables, as functions of other endogenous variables or other predetermined variables or even random variables. Now, the structural parameters in this model expresses propensities, elasticities and the parameters of economic theory. A structural parameter explains the direct effect of each explanatory variable on the dependent variables. And for the indirect effects of the explanatory variables can be calculated by the solution of the structural system. Let's take an example that we have our basic Keynesian model. We have our basic Keynesian model. Ct is equal to B naught plus B1 yt plus ui, and it, the investment function, is equal to alpha naught plus alpha 1 yt plus alpha 2 rt plus ut, and yt is equal to Ct plus it. This is basically the identity function. So we have the consumption function, the investment function and the identity function. Now here Ci and T, as they are being determined in the model, we refer to them as endogenous, and the exogenous variable is R, and U1 and U2, they are the random terms, random variables. Now, this was a simple model we had. Now we move on to the reduced form of the same model. So we are now going to the reduced form model. Now here, the reduced form of a structural model is in which the dependent variable, we should not be using the dependent variable, rather we should use the exogenous variable, that is an endogenous variable. That is, the endogenous variables are expressed as a function of predetermined or exogenous variables. That is, the endogenous variables are expressed as a function only. Means on the right hand side there will not be any endogenous variable present over there. Like if you have a look over here, we say that yt is being determined in the system, but yt is also over here. This is the case of a structural model. In a structural model, it is the endogenous variable is also present on the right hand side of the equation. But when we go to the reduced form model, when we will change this model into its reduced form, we will find that there is no variable endogenous present on the right hand side of the equations. So what we do? We first take our identity equation, that is equation 3, and it is yt is equal to Ct plus it. You have this, yt is equal to Ct plus it. Now when we have this, then we know the function of Ct. We write it here. This is nothing but your CT. And this other function, that is, this is the investment function, that is the function for I. We write it over here. So we open the bracket, beta naught plus beta 1 yt plus ut plus alpha naught plus alpha 1 yt plus alpha 2 rt and the error term vt. Now we try to bring all the y terms together in the right hand side itself. So we write yt 1 minus we take this term and we have another term. So these terms we can write it together. So we take yt common and then we write 1 minus b1. Just a second, this has to there is misprinting over there. So we take this to the left hand side, we take this also to the left hand side, and then we take common yt common. So what is left with yt with bracket open 1 minus beta 1 minus alpha 1. This is equal to the left terms beta naught, alpha 2 rt, ut, vt. So this is what we write over there. Finally, we write this equation as yt is equal to, we take this term to the denominator side, to the denominator of the right hand side. So we can write yt is equal to alpha naught plus beta naught divided by 1 minus beta 1 alpha 1 plus alpha 2 divided by 1 minus beta 1 alpha 1 plus ut plus vt divided by 1 minus beta 1 alpha 1. This is the reduced form of this equation. This was the structural equation. This is the reduced form of it. So from this, the third equation, yt is equal to ct plus it has been written as a reduced form now. Now remember this term yt. We write it over here, the same term yt is written over here. Now we substitute it in the consumption function. What was the consumption equation? Ct is equal to b naught plus b1 yt plus ut. This was my consumption function. So now in place of y, we incorporate the entire function of yt which we have derived just now. So this is written as it is over here. Now first of all, we open the bracket and b1 is multiplied with all these three terms. So we can find beta 1 alpha naught plus beta 1 b naught over here. Here also alpha 2 multiplied by beta 1. Here also beta 1 ut and beta 1 vt divided by the same 1 minus beta 1 minus alpha 1. Now we have an ut term over here. We add this ut term to the third term and we have a beta naught over here. We add this beta naught to the first term. Upon adding and taking the LCM and then opening the bracket, what we get is beta naught multiplied by 1 minus beta 1 minus alpha 1 plus beta 1 alpha naught plus beta 1 beta naught. This term remains the same as it was, alpha 2 beta 1 divided by 1 minus beta 1 minus alpha 1. And the third term, when we are incorporating, taking the LCM, we are multiplying ut with this entire term. So we get ut 1 minus beta 1 divided by alpha 1 plus this original term which we were having beta 1 ut plus beta 1 vt, and this whole term divided by 1 minus beta 1 minus alpha 1. So this is the equation which we have got as of now. The same equation from this previous slide has been written over here. Now we open these brackets. We open these brackets and we cancel some of the terms which are similar but with different signs. So what we are left with it is Ct is equal to beta naught plus minus beta 1 alpha 0 plus beta 1 b 0, beta 1 b naught divided by 1 minus beta 1 minus alpha 1 plus beta 1 alpha 2 divided by 1 minus beta 1 minus alpha 1 multiplied by RT plus beta 1 UT, I think here RT is missing, plus beta 1 UT plus ut plus beta 1 vt divided by 1 minus beta 1 minus alpha 1. So this is my reduced form of the consumption function. In the previous slide, we had got the reduced form for the identity equation. Here we have found the reduced form of the consumption function. Same thing. Now we take the investment function. If you recall the investment function we have defined is it is equal to alpha naught plus alpha 1 yt plus alpha 2 rt alpha 2 rt plus vt. This was our investment function. The same process which we had applied over there, we in place of yt we write the entire this term in place of yt. Then we open the brackets. When we open the brackets, and then so what we get, we multiply, we incorporate this also over here. So we open the bracket and take the LCM as and where required. So this term up till here, it is written in this format. Plus this is alpha naught plus alpha 1 alpha naught plus alpha 1 beta naught divided by 1 minus b1 minus alpha 1 plus alpha 1 alpha 2 divided by 1 minus b1 minus alpha 1 plus alpha 1 ut plus alpha 1 vt divided by 1 minus beta 1 minus alpha 1. And then this term comes as it is, that is alpha 2 rt, and this term also comes as it is, that is vt. So now we can incorporate this vt also over here. So finally we get the equation as it is equal to alpha naught minus alpha 1 b naught plus alpha 1 b naught divided by 1 minus b1 minus alpha 1 plus alpha 2 1 minus b1 divided by 1 minus b1 alpha 1 plus alpha 1 ut plus vt bracket 1 minus b1 bracket close divided by 1 minus beta 1 minus alpha 1. So we have now three equations. We are just writing these three, we are just putting all the reduced form together. This is the reduced form for CT, this is the reduced form for IT, and this is the reduced form for RT. So we have written all the reduced forms over here. There one thing, I think we have missed something. This RT, it should be over here. We have missed it over here. Please take care. Please note this correction. This RT, we are missing it over here. So we have missed this RT over here. So finally, so those three equations, I am writing it over here just for your reference. Please note this correction of RT over in this term. This can be written as, in the reduced form, as CT is equal to pi 10 plus pi 11 plus Z1, IT is equal to pi 20 plus pi 21 plus Z2, YT is equal to pi 30 plus pi 31 RT plus R3. What is now? This we can further denote like this, or here also we can see it like this. Pi 10 is nothing but this value, pi 1 is nothing but this value, pi 20 is nothing but this term, pi 21 is nothing but this term, pi 30 is nothing but this term, pi 31 is nothing but this term. So instead of writing the entire term, we are just denoting it by pi 10, pi 11, pi 12, pi 13, and likewise. So here that thing has been written in detail. Pi 110 it was nothing but this function, it is written over here. Pi 11 is nothing but this function. Pi 20 is nothing but this function from IT. Pi 21 is nothing but this function over here. Again, here also RT is missing. Please note this correction. And pi 30, we can, this is nothing but this equation. Pi 31 is nothing but this equation. So these are the equations and how you can write it as a reduced form. Now, the reduced form parameters measures the total effect of a change in the exogenous variable, on the endogenous variable. Now, let us to understand this direct and indirect effect. We take one of the equations. One of the equation is yt is equal to pi 20 plus pi 21 rt plus z2. Now, this pi 21, this we can see from the previous slide, this I am referring to this pi 21, this value, this value. This pi 21 I have got from here. So, this I am referring to this value, I have taken just for one example. Now, here 21 measures the effect of a unit change in rate of interest on the value of investment. This, if I do some algebraic manipulation, I can write this pi 21 as this was the equation which we had from our reduced form. This, if I do the algebraic manipulation, I take pi 2 outside, then in the bracket 1 plus pi 1 divided alpha 1 divided by 1 minus beta 1 minus alpha 1. This I can further do the algebraic manipulation and write pi 21 is equal to, I take alpha 2 separate, alpha 2 plus alpha 2 alpha 1 divided by 1 minus beta 1 minus alpha 1. So, this is the effect of change in the exogenous variable on the endogenous variable, or it measures the effect of a unit change of R on investment. It is made up of two things. This is what you refer to as the direct effect, and the second term is referred to as the indirect effect. So, basically the direct effect consists of two parts. First, that is the direct effect on investment through the coefficient alpha 2. As it is, you are getting it from the structural equation itself, and there is an additional effect. There is an additional effect due to the fact that as there is an increase or decrease, it affects investment, and investment affects income, which in turn affects investment. Finally, YT, that is your income, affects your consumption, which in turn affects YT and hence IT. So, this particular thing is explaining the indirect effect. This is the total effect is a part of total effect can be composed. It should be 0 over equal to sign over here. Total effect is equal to your direct effect plus the indirect effect. Next, we go to another item over here. We will another item, that is what's a recursive model. We are having the use of recursive model over here in simultaneous equation model. They are special models which satisfy certain special conditions, and the beauty of it is if those conditions are satisfied, you can use ordinary least squares method. So, if the equation can be arranged in such a way that the first equation contains only predetermined as explanatory variable, and second equation contains predetermined variables and endogenous variables, and so on. See, so y1 is a function of only x1 and x2. But next time there is x1 and x2, and there is again y1 also. In the third time there is x1 and x2, now there is y1 and y2. So see, simultaneous equation can at times take this special form. This is called as recursive model. If the equation of the structural model could be arranged in such a way, then we can call it recursive model. That is this type of arrangement, that the first is only predetermined, and then we have predetermined and the earlier endogenous variable. This system is also called by the name of a triangular system, because the coefficients of these endogenous variables form a triangular form. We will see it later. Then but what we want to emphasize over here right now is the main advantage of recursive model is that OLS can be applied directly on each equation to estimate parameters. Let's take an example. We have the demand function is equal to alpha naught plus beta 1 plus alpha 1 p plus u, and the supply function is equal to beta naught plus beta 1 p plus beta 2 w. W can be say weather plus u2. Yeah, w is weather, and then we have the third equation, that is the identity equation. So what we are just doing, we are initially based on the identity equation, we are writing the demand is equal to the supply. Then P is over here, P is over here, we will try to solve for P. So we take the P, to take the P's together, we take it to this side, and this term we take it this side, these two terms we take it this side. So what we have, beta 1p minus alpha 1p is equal to minus beta naught minus beta 2w minus ut plus alpha naught plus u1. Now in terms of p, I am taking the p out common. Our purpose is to write this full equation in the form of p. So p multiplied by beta 1 minus alpha 1 is equal to the right hand side of the equation. Then finally we take this to the denominator of the right hand side. So p is equal to alpha naught minus beta naught divided by beta 1 minus alpha 1 minus beta 2 w divided by beta 1 minus alpha 1 plus u1 minus u2 divided by beta 1 minus alpha 1. Now we substitute this value which we have just now, this is the value which we have derived just now, into P. We take the demand function and we substitute the value of P which we have just now derived into this demand function. So we can write the new demand function in this form. Again we open the brackets, so D is equal to alpha naught plus alpha 1 alpha naught minus alpha 1 b naught divided by b1 minus alpha 1. Again we multiply with this term also, your alpha 1 b2 w divided by b1 minus alpha 1 is again multiplied with this term. So alpha 1 u1 minus alpha 1 u2 divided by beta 1 minus alpha 1 plus u1. Now we add a2 over a naught over here, and we add u term over here, taking the LCM and rearranging the terms. Finally we can write it as D is equal to alpha naught beta 1 minus alpha 1 beta naught divided by beta 1 alpha 1 minus alpha 1 beta 2 divided by beta 1 minus alpha 1 w plus beta 1 u1 minus alpha 1 u2 divided by b1 alpha 1. So now we have got the reduced function of D. So by inserting the P term, we got a reduced model of P and we got a reduced form for D. So now we can take this as alpha 1 0, we can take this as alpha pi 2 1, pi 1 1, we can take this as, yeah, no, just a second, this has been written top. So this we are taking as 2 0, this is 2 1, and for the demand function, this function is written as pi 1 0, and for this function is written as pi 1 1. So first we are writing the demand function is equal to pi 1 0 plus pi 1 1 w plus zi is this term, the error term, and p, the price function, is written as pi 20 plus pi 21 w plus z2. So pi 20 is this, pi 21 is this, pi 10 is this, pi 11 is this, and z1 and z2 are the error terms. So this is how you write the reduced form model. I hope this is clear. So the thing is, these two are related to the P function and these two are related to the D function. So this is how you can write a structural model into its reduced form. Let us take one more example. Take the ISLM model. So in ISLM model, goods market explain the combination of interest rate and levels of income or output such that the planned saving is equal to income. So now we can write Ct, the consumption function, as alpha naught plus alpha 1 Yt minus alpha 2 T2, that is the taxes, and tax is a function of beta naught. You can say this is the lump sum tax plus beta 1 Yt, the marginal propensity to tax, and that is as you progressive taxation, not marginal propensity tax, the progressive taxation, that as your income increases your taxes also increases. Then It is equal to C naught minus C1 RT, where R is the rate of interest. Disposable income YDT is equal to Yt minus the taxes, and GT is your government expenditure. There is a bar over it, means it is given from outside, we are not determining inside the model. And then we have our identity equation, Yt is equal to Ct plus It plus GT. So first thing is we substitute Ct, It, Gt in income equation to get the reduced form of the equation. This is the first thing. Where is this? Means you incorporate this, then you incorporate this, then you incorporate this. All these things are incorporated into the model. So we can write it as alpha Yt is equal to, it is given over here also, so we can write, we just taken t in the minus format. So we can write it as alpha naught plus alpha 1 Yt minus alpha 2 t. This is my consumption function, then my investment function, and then G. We open the brackets. So we open the brackets and take all those terms which are having Yt in, we are taking all those together. So alpha naught plus alpha 1 Yt minus alpha 2 B naught plus B1 Yt plus C naught minus C1 RT plus T. So this T, what is in the bracket over here, we are incorporating the taxes. This tax equation, in place of T we are writing it over here. Now what we are doing, we are now going to multiply this, alpha 2 B naught we get and alpha 2 B1 Yt we are getting, rest the terms are same over here and here. We have just opened the bracket. So finally we take all the Yt terms to this side, and the terms which are not having the component of Yt to the right hand side. So we can say Yt is equal to alpha naught plus alpha 1 Yt minus alpha 1 Yt plus alpha 2 beta 1 Yt is equal to the remainder of the term, that is alpha naught minus alpha 2 B naught plus C naught minus C1 RT plus G dash or G bar. Then we take Yt common. So this term, that is 1 minus alpha 1 plus alpha 2 B1, it can go to the denominator. Now we take it to the denominator, only we keep the RT term as a separate, but we are just taking it to the denominator. So now my final equation is Yt is equal to alpha naught minus alpha 2 beta B naught plus C naught plus G bar divided by 1 minus alpha 1 plus alpha 2 beta 1 plus minus C1 RT divided by 1 minus alpha 1 minus alpha 2 B1. So this is my reduced form model of the income. Now this is my Yt, and this is your, this term I denote as pi 1 0 and this term we denote as pi 1 1. Your IS equation is, you can say, and this we have just now derived it from here. We are just deriving it from here, this equation. Now we can say that this is equal to this term, this much term is equal to pi 1 1 and this term is equal to pi 1 0. So we can write IS equation Yt is equal to pi 1 0 plus pi 1 1 RT, where pi 1 0 is this term and pi 1 1 is this term. So this is, we have defined the IS equation. Now we go to the LM equation. LM equation is where demand for money is equal to the supply of money, or this is the money market equilibrium. Money is defined as the different combinations of interest rate and level of income at which the demand for money is equal to the supply for money. Demand for money, we can define it by this function, gamma 0 plus gamma 1 Yt minus gamma 2 RT, and demand this the demand for this supply of money. The supply of money is denoted by M bar, that is fixed. It is fixed by the monetary authority of a country, and we say that the money, the demand for money is equal to supply of money. So we can write it as your supply for money is equal to the demand for money, which is gamma naught plus gamma 1 y1 minus gamma 2 r2 rt. So this is my LM equation. Now this LM equation we can write it, we will basically want to write it in YT format. So what we can say, this is gamma 1 YT, we take YT to the, we take the remainder of the terms to this side, to the right hand side. So gamma 1 YT is equal to minus gamma 0 plus gamma 2 RT plus M bar. M bar, that is the fixed M, the money supply. So here it is y gamma 1 YT. So we take YT to the right hand side as the denominator. So YT is equal to minus gamma naught divided by gamma 1 plus 1 minus gamma 1 M bar plus gamma 2 gamma 1 RT. Now this we can say is pi 20. This we can say is pi 21, and this term we can say is pi 22. This one is pi 22. So we can write your reduced form of the income equation is YT is equal to pi 20 plus pi 21 M bar plus pi 22 RT, where pi 20 is equal to minus gamma 0 divided by gamma 1, pi 21 is equal to 1 upon gamma 1, and pi 22 is equal to gamma 2 divided by gamma 1. So this is how you get the reduced form model.